The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality was stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone, welcome. My name is Nathan, otherwise known as Old Man Bills. We have Shawn here today, man. What's going on, Shawn?
Oh, I'm doing pretty well, thanks. I'm pretty excited to share some more experiments with the Ravs.
Right on, man. We're excited to see it. I'll go ahead and put it up for you.
Awesome. All right, let's get started.
You probably have to start it over.
Oh no, how are we looking?
Oh, dude, you're good. Just go ahead and get to the beginning of where you wanted to start.
Awesome. All right. Well, hey guys, it's great to see you all in the chat. I always appreciate your guys' support, your kind of words of encouragement. Excuse me, I'm fighting a sore throat, so excuse me. So I might be a little raspy. Oh boy, sorry, not a good start. Okay, so I thought I'd start here. What we're going to be talking about is the RAV. It's just the name I gave to this phenomenon. As I've mentioned many times, my inspiration came from R.A. Ford. He wrote a book 33 years ago. I read it, and he talked about this phenomenon. And I thought, well, let me see if I can run with it. And so this is my attempt to run with that. So when I say RAV, I'm saying is that it's a resonant arc vortex. It's a spinning ball of plasma, but it's spinning at its resonant frequency. The significance behind this photo here is that the neon tube is next to it, but it has zero energy that's coming from the RAV, and that's because it's exhibiting complete confinement. Now, I know Nathan and Joe had a really great live stream, and they looked into this, so I would recommend their live stream. I think it's a couple weeks ago, but they dig deep into this idea of confinement. And I just want to start with this because this is really the reason why I see this as just more than just an art. Okay, you can strike a piece of metal against electricity or something that has electricity flowing through it, and you're going to get an arc. But are you going to get an arc that confines all of its energy? Are you going to get an arc that spins? Uh, you're just not. So that's what's really special about this. So I thought I'd start with this. Now I was really working on what is going on inside the RAV, the different phenomenon, the different forces. This is what I came up with. Um, the prominent force here is the E times B drift. So E is for the electric field, B is for the magnetic field, and that seems to be the force that's causing it to rotate like a merry-go-round, if you will. Um, and then what happens is that as it moves across the clay, and this is having this orbital action, it's also having a drift, which then moves it across the clay. So to give you an example, it's like a kind of like a tornado moving across the land. And so this EB drift here and this ER drift creates this rotation, and it creates this movement that you'll see. There are other interesting theories. One of them is the magnetic pinch, which I think is interesting. But we're going to cover a lot of stuff. I'm going to update this as I go over my notes from Joe and Nathan's lecture, and and really get this down, I think, pat, but this is a start. So I thought I would do something conventional here. I usually just go through photos and videos. I kind of wanted to just give a little bit of explanation of the phenomenon that I was able to discover. And so it comes in 4 phases, even though I'm going to only have 3 photos. But, but the first photo is going to be of the first 2 phases. So here we have phase 1. An initial arc ionizes moisture and minerals, talking about the clay and the water. It produces an unstable, noisy waveform. So if you look at the O-scope, it just looks like a whole bunch of noise. But then on phase 2, you have this, what's called dielectric charging. So the wet clay acts like a capacitor, but it's a capacitive reservoir. So it's basically a capacitor that provides more and more voltage potential. So that way, then you have a higher powered, if you will, or high energy plasma. The water droplets concentrate the electric fields. This was interesting that I found this out, is how the water droplets are holding the electric fields concentrated. So let's take a look at phase 1 and 2 together. This is phase 1 and phase 2. You're seeing that it doesn't have a lot of form, though Nathan and Joe will probably find some awesome form in this. But I'll just let you just want to say that it's given that sort of chaotic form, but you're getting the high voltage capacitive effects. And you can almost kind of see in the white here, it's starting to compress, whereas these outer violet and blue layers haven't yet been pulled in. So you're starting to see that it is coming in, but not quite there yet. And then phase 3 is the birth of the RAV, the birth of the RAV. Plasma sheaths form, collapsing inward into a vortex. One of the terms that I've learned in my research of plasma is that it forms sheaths. So if you can imagine, sort of like peeling an orange, but having multiple layers of peels, they call them sheaths. And so the reason why they call them plasma sheaths is because each layer has its own temperature range. It has its own, I would say, its own speed or vector, velocities, has different velocities and temperatures, and they actually form barriers between each other. Nathan was referring to them early as nulls. Boy, oh boy, I don't have my lemon tea. So you have these sheaths, and then there's a high electron density. These sheaths are comprised of a high electron density. And then when the RAV is fully birthed, it goes into a silent operation, which indicates energy confinement. So energy of escaped plasma, of sound, all of the different energies, vibration, are all contained, and you can hear it. It goes immediately silent. And so I have a photo here, and this is basically at 1 second before it's a complete birthed RAV. And what's so interesting to me is that it's actually larger than it is once it's fully birthed. So when it pulls all together, it's about 25% larger than the fully formed RAV. Now, if we go back to last year, it's just phase 4, which is a sustained rotation, stable triangular waveform with 3 frequency states. I'm going to be talking a little bit more about that a little bit later. I'll show you on the O-scope. It has a little bit more of an FM radio modulation versus an AM radio modulation. And it's a triangle wave, which is also interesting. Now, it suggests rotation is coupled to surface charge oscillations. This one's also talks just about, again, about the sheaths of plasma that are oscillating. And it says oscillating, but I think it's a circular oscillation, so I'm calling it revolution or rotation. And then it says here possible E times B drift motion, which in my other experiments, I discovered that it is. It does contain E, electric field, B, magnetic field, drift. And so here's the fully formed RAV. It goes completely silent. Um, Nathan pointed out something very clever that I missed, but the reflection of my camera, my phone screen here, it has a refraction here of what's going on, which seems to be representatory of some of its properties. And you can see here that it has layers, and it even has some satellite here orbiting the center here. And what's fascinating is that this is a macro scale of what's going on at the atomic level. If you have the nucleus of an atom and you have the surrounding electrons, and then of course it's a very small micro version of our solar system and even our galaxy. So this is very fascinating because you see this pattern throughout creation, to be honest. All right, I think we covered most of this. So I'm going to pass by my slides. So I left this slide because if you're wanting to build RAVs, this is shows you how not to do it. This shows you that why your RAVs are stalling. And the reason why they're stalling is because you have too much moisture in the clay. So if you're getting something like this, basically your pot's been in the water too long. And so basically the whole clay pot is a conductor. And so this beautiful pattern here is about 30,000 volts DC on a wet clay plot or pot. And I thought I'd share this. Shared it last week, but it's so beautiful that I thought I would share it again. A lot of art in plasma, it's just amazing. There you go. You can see each energy level has patterns in it, which we can talk more about later. So here is another picture. The reason why I'm sharing this one is because the tube is actually sitting in the water with the pot. So the other ones you've seen, it's not in the water. So this one's actually has in the water. And so I did this because when the RAV is fully formed and it's sitting on the cathode water electrically, it's still, the RAV, when it's formed, it still lets no energy from the water or anywhere to go in this neon tube. That's mind boggling because I've literally now connected this neon bulb into the water, and the neon bulb here has a metallic here, so you literally have a cathode at the bottom connected to this neon bulb, and then this wire here is the anode, and you have 30,000 volts of plasma, and it's completely empty. So this is kind of another proof, if you will, that this is a very good argument that I have the RAV has achieved complete confinement. I think this is another take. Now this one's outside, but I think it's a different video than I shared. What I want to point out though is see how the water drips down? It doesn't matter though. For some reason, it still insists on forming a circle. So that always interests me. So I thought I'd just share that real quick. This bright flickering here, it's a lot brighter in person, as you can imagine. And I'm working on building an instrument that's going to measure that blinking and then see if I can read a true rotational frequencies by using the photons, because using the electromagnetic aspect, it seems like the oscope really has a tough time in locking into the exact frequencies that are being observed. Now, I think the slide just got stuck in here by mistake. This is salt. I put a very, very, very light salt content in the Q-tip, and so it creates a really beautiful yellow RAV. I thought that's pretty cool to share. But working with saline water, it's like here you can see it's pretty chaotic. This is me just trying different things. This is a ceramic cloth that's used to insulate kilns. And I thought, well, it's ceramic, it's porous. Maybe I can get some plasma to work in it. What was interesting is it did create some spheres of plasma inside, but I couldn't really get any frequency or anything from it. But I'm trying different materials, and you're going to see me do more of that later. And it's making a little bit of fumes. So I have R2D2 over here on the right, taking in the fumes, so you see a little bit of smoke. But yeah, you can see maybe some interesting plasma action going on inside. I thought it was just worth sharing. It just keeps making these, tries to spin off spheres really inside. So maybe there is some rotation going on at some point here. You can see the smoke though right into the fusion filter. This was a giant rock salt lamp, and I haven't had a chance to cut it and sand it so it's flat. What I've learned in all of my experiments is that the flatter the surface, the better the RAV. So you're seeing here that I'm getting a RAV here and there, but nothing really steady. It is interesting that one's jumping over here, and what's actually happening is it's going under the salt and appearing over there, which is pretty interesting. Other than that, I couldn't do a whole lot with it. It puts out some noxious fumes too, so I have to wait for the heat waves to pass so I can go in the garage. My garage is not air conditioned. All right, so this is my highly complex scientific environment for creating RAVs. So yes, you might want to take a picture of this, and yeah, it'll take you months to figure out. So on the right here, I have this eyedropper. What this does is it's a high-tech device for allowing the right amount of water to be then absorbed into the clay to sustain a RAV as long as you want. So I call this the sustain RAV as long as you want dripper. Yeah, I'm being really facetious. I'm sorry. But seriously, this is a setup right here. This is just a metal bowl, just connected to the negative. It's a high voltage DC power supply to the left. Alligator clip holding this little tiny thin piece of wire. Just needs to be rigid. I even used aluminum, so steel, aluminum are great. I don't use copper because it's at this thinness here, it's too wobbly. And so when I dab it with the Q-tip, that gets it started. And then when I keep adding water with the eyedropper, which is maybe every couple minutes, you'll sustain a RAV indefinitely. So this is the secret of creating indefinite RAVs. And it's great because now I can start performing different tests on them. I don't have to sort of watch it dance across a horizontal wall and phase in and out and try to study it that way. This is like very steady, and to perform scientific tests, this is necessary. So, and if you're looking for eyedroppers like this, they sell them on Amazon for super, super cheap. And so now I'm showing this setup where that you just saw, and I'm going to just let you know that now it's a self-feedback system with that eyedropper. Now, at first, I was going to build all these complicated voltage feedback systems in order to maintain the RAV here, but all we needed was an eyedropper and a flat piece of clay. And look at it; it'll sustain as long as you want it, and it's pretty cool, pretty awesome. But this is now a place where you can really dig into research, and that's what I've been doing. Some of the research I want to do is requiring me to build devices that don't exist, because this doesn't seem to be a very common phenomenon. A spinning ball plasma like this, self-contained. You can even listen to it; it's perfectly silent, and it's just amazing. Just a fascinating phenomenon. And I know you guys know this, but it's a lot brighter in person, so it's not really doing it justice here. This is quite a bright little ball of plasma. So I think I let this run. There you go. See, this is a setup. Not bad. Yeah, I'm just going to let it run here because I think it goes for 2 minutes, but I just want to kind of emphasize the point that it's a self-stabilizing. Well, I need to give it a drop of water here and there. But here you have it. The feedback loop for the wrap. Oh, I wanted to show you this. See, this looks like smoke. What's happening here is as the clay heats up, the water in the bowl is evaporating, okay? So there's no smoke, no burning, okay? That's another thing that fascinates me. It's just all there is a vaporization. There's a vaporization of the minerals in the clay. There's a vaporization, I can say that word, vaporization of the water, the moisture, and it's such a hot steam that it's actually invisible. It's that steam that is so hot that you can't see it. When I was in the Navy, I had a friend who was on a steamship, and they run on steam power that's so compressed. When they have a steam leak, they have to check it by using the like broomstick handle. And as they move that broomstick handle wood next to the pipes, when the broomstick handle cuts completely in half by an invisible force, they know that's the steam leak. So high pressure steam is basically invisible. I believe that because there's no steam, that it's that kind of high pressure steam, or an atomized water droplets might be another way to say it. But as the clay heats in a bowl of water, the bowl of water is going to, of course, evaporate. So just want to describe those different phenomenon. So I'm going to run some tests, but first of all, you have to check out how noisy your setup is. So I'm just kind of holding my my oscope probe. I know you guys do this on your testing, but I thought I'd kind of walk you through how my brain works. So that's the kind of garbage noise that's going on without anything going on. I'm going to be building a Faraday cage because I think my setup's too close. But now you'll see that my oscope is on the power supply. It's on the DC power supply. And in order to create high voltage, you need an oscillator. And in order to have an oscillator, I'm sorry, when you have an oscillator, it actually is going to have, it's going to basically transmit its oscillation. So in here, right here where the tip of the probe is the little oscillator. And here you have this sort of H or M wave noise. But it's good to see this because I now know that if I get this from the RAV, I'm not getting it from the RAV, I'm getting it from the power supply. This was a very interesting wave. I guess it's more M wave than H, but not only does it have its own sort of resonant frequency, it has these little rings here, which I think is fascinating. Resonant rings upon its resonant oscillation. So I thought that was really pretty interesting. Here's another thing that I wanted to look at was the DC just going through the air and hitting the metal bowl because I want to be able to, again, pick out the frequencies before I measure the RAV. I want to know what the different frequencies look like. And it is pretty interesting how everything has a frequency. Now, I know everybody probably already knows that, but it's fascinating that DC has so many frequencies. DC is a flat current, yes, but it doesn't mean it doesn't have noise or frequencies from it. So this is kind of what proves that. So now it's time to get my pretty RAV going, and here I'm getting that really crisp, clear, very high slope, 104. It has three frequencies: 100 kilohertz. I'm sorry, 96.1 kilohertz, 100 kilohertz, and 104 kilohertz. So what's happening here is that the amplitude doesn't change, but if you'll notice, it kind of squeezes, it compresses and contracts, compresses and contracts. And it does it very small, very quickly. But it's interesting. I don't know if it's indicative of the different rotation rates that are in the different layers. of the RAV that might explain it. Um, and that would be awesome if that's what it is that it's actually picking up three plasma sheaths as they're rotating. That seems to be an interesting theory. But yeah, it has these hard and fast three resonant frequencies every time I test. So I decided, okay, let's have a little bit of fun with a magnet. This is a ring magnet that I took from a microwave oven. And this was my first test with it. So now I'm trying to create a RAV. So all those parameters are set, but now I'm putting it in the middle of a pretty powerful ceramic magnet. It's important to note too that ceramic does not is an insulator. That's very helpful here. If I use a neodymium magnet here, it wouldn't look anything like that. So you can see the RAV is really trying to form. It tries so hard, but the magnetic lines of force and the magnet just rip it apart. So you sort of have this battle going on between, and the RAV just never really wins. It just starts, and the magnet just will not have it. And so I thought that was fascinating. So now I'm going to flip over the magnet. We'll try it now with the different set of the north side up now to the south side up. We're going to again go through the same experiment. And look at that. The magnet actually helps. And it also only helps. It makes the RAV super huge. Now, it's not perfect, which I have to do some tweaking. But this setup is making bigger RAVs. As you saw earlier, they're giant RAVs. And so I thought this was worth sharing. Pretty cool stuff. You also might see too here, there's this, let's see if I can catch it. I'm not able to do it. This sort of cyclone kind of waveform. So that was happening earlier. Now, granted, this magnet again is not perfect, but it is aiding a lot more. And you can see that it's sort of etching now the clay. So the minerals in the clay are the fuel for this plasma. The water droplets maintain or encapsulate the electric fields, whereas the fuel, if you will, is the minerals in the clay, and it's not burning the clay; it's incinerating it, or I'm sorry, even not incinerating, but it's vaporizing it. What does vaporizing mean? I don't know. It's just the best word I can come up with. But thought I'd show this twice. Pretty incredible. So there is a difference. There's a lot of magnetic forces going on inside the RAV that this magnet would have either a positive or negative effect on it. So the RAV is definitely a magnetic object. Definitely. Not just electric field. There's a whole lot of magnetism going on. It's interesting because it's trying to create a RAV over here. The magnet wants it in the middle. So I think the middle exhausts its fuel. You're kind of seeing that too. All right. Not sure what I'm doing here. You think I know all my slides? Sorry, I think I was just enamored by the. Oh, this was just another with the magnet facing in the right way, where it aids in the creation of the RAVs. I wanted to show you that it makes much larger RAVs. So this is a lot more balanced, and this RAV is about twice or three times bigger because it's in this magnetic well here of this ring magnet, if that makes sense. So I thought that's incredibly good to know that magnetism can make larger RAVs, because I've been really working on wanting to make larger RAVs, and now I figured it out. Now, what I'm trying to show you here is I'm stacking the clay because I want to show you what's going on under the clay with a more visual. So, because you never really see it, all you see is the RAV on top of the clay. Where here you're going to see the RAV, how it works under the clay. And so, and how I'm simulating this is I'm putting layers of it. So see the blue on the bottom? So that blue on the bottom is the plasma that's going on under it that you can't see. And what that's doing is that's part of creating a wrap. So you have a wrap on top, but you see this blue layer. So you have this, but it's not just a little spot at the bottom of the clay, but you have the whole piece of clay sort of working and extracting and pulling up the energy from the water droplets. There you go. You see it again in order to build the raft. So pretty cool stuff. This is pretty cool because again, we miss this kind of stuff on the underside of the clay, and I think this represents that pretty well. And guys, I don't have any rhyme or reason. I just either listen to you guys and I'll try it, or I just throw things in. And I'm kind of like the baker who just bakes by fun and eyeballing it. Here, I thought I'd sprinkle a little bismuth. Everybody talks about bismuth. I thought, well, I have a little bit. What can we do with bismuth? What will the Rav do? Um, so let's see what happens here. I have all the conditions to make a Rav. So the only difference is it has the bismuth. Um, I will say that the plasma discharges are very, they look like broccoli, pieces of broccoli. I'll also note too is that it formed a perfect, almost a perfect sphere of bismuth, and then it left quickly, leaving a pit in it. Um, so it's really fascinating how it sort of shapes the bismuth. Because at the end, I'm going to have actually a ball here of bismuth once I cool it down. So, oh, it's actually going to divide into two. But the fact that it tends to, it actually, what's the word I'm looking at? It sculpts metal. Of course, easy to melt metal like bismuth. But yeah, so that was interesting. Not to not know. I don't know what I'm going to do with it, but that was worth sharing. Everybody likes bismuth. Yeah, that's a very interesting Rav. I put an O-scope on each side of a Rav. So blue is on the right side, the yellow is on the left side. And it looks promising to me because one of the biggest things I have to prove for me is that it's rotating. And so one of the ways I'm going to do it is I'm going to create a device called the photon harp. And I'll show you what that device is going to look like here in a second. I'm showing you that my feedback device to keep the wrap going, the dropper, water dropper. I'm not sure what I'm going to do here. Some of these I'm adding things to it, so not sure I did here. Maybe I'm just trying to show you the eyedropper, but again, I'm telling you, once you get this set up, I mean, you got a ball of plasma to play with. It's so incredible. Um, I think I'm watching the O-scope because you see me drifting. I'm losing concentration here. So, oops, there you go. I'm awake again. I thought though in this video I show you the O-scope, but maybe I don't. Oh, I do. Okay, good. So there's that beautiful triangle wave, almost sawtooth wave for you, Ian. Um, there you have it. It's definitely has a frequency. Okay, here someone requested in the chat last time that I put a piece of crystal. So here I put a piece of quartz. And then basically I had the same parameters of a RAV. I had a little, what do they call the quartz? Half sphere with all the quartz inside. And I just chucked it on the ground and took off a piece of quartz here. It's interesting how it funnels or it keeps the plasma in kind of a thick wire, thick, I don't know, river to then produce a bunch of pieces of broccoli. Um, the crystal really guides the stream of the plasma based on its geometry. And of course, it needs to eat minerals and it needs water, so it's going to move in conjunction with the dimensions of the crystal, and it wants to create a rave up there, a rav up there in the upper left-hand corner, but I think it has to bend around too much because the crystal's saying no, you're not going any further. So it has to go around the crystal. But someone suggested it, and I had fun. I do try to listen, guys. I do try to write it down, and do try to experiment. I know I miss a lot of what you guys say, but I'm trying. So here, someone requested put a little dab of oil. So here, put a little mineral oil and see what happens. I forgot to turn the camera on when it started, so it's a second or two late. But yeah, this is what mineral oil looks like on clay set up to make a rav. What's different is the orangish yellow tendrils that surround it. I've not seen that before. There's something going on the outskirts. Something about maybe the oil being pushed out, or maybe the oil is being ionized. But there's something ionizing that's not part of the clay and water. So these might be oil ions. Once it gobbles up the oil, it wants to turn back into a rav. So you can see ravs, they want to win in the end, I'll tell you. And they want all the energy, every last bit. Look, every last bit. And the oil won't give it. Oh, it did. No, for a second. Okay. I don't know. Maybe I'm making too much of a anthropomorphism or zoomorphism. I forget. I keep talking about it as if it's alive. Look at that. So that's mineral oil. Interesting. I hope you find that as interesting as I did. Let's see. Not sure what this is. Yeah, maybe something will happen here in the end. It is interesting that it's got these purple tendrils that are gripping it, even though it's a pretty darn solid rav. So maybe that's why I'm sharing this, is that it's not your normal rav. It's a rav with that like a purple haze. And that's probably why I was showing you this, is that because that's not normal. On average, it's always all the plasma sucked in. Here I thought I'd do it upside down. This was not easy to do. A lot going on here, but what does the rav do upside down? Here's my attempt. And there you go. Pretty incredible that it just forms in pretty much any geometry, or I'm sorry, any angle. And so this is upside down rav. I do want to do some study on this because there's something about the shape. It's not quite as spherical. It's more of an oval, which of course makes sense because it's the gravity. But I didn't think gravity could be so have an effect here, being so light and small. Also seems to have this kind of little Saturn ring going on. So I'll be spending more time on this, but I thought I'd share the upside down wrap. I don't have the greatest of camera angles either. I think it would look a little bit more uh, like a circle than a oval. So that was, I took like 10 videos. They all failed. This was something that I kind of picked off the conversation with Joe and Nathan when they talked about these, how it can look like before the RAV forms, it has sort of these, the look of what you'll see as electron probability clouds. They never really know the orbit, if you will, of electrons because of the probability statistics of it could be in certain areas with higher probabilities than others. So I kind of drew it around here thinking, okay, well, here's another one, but it's on the bottom now. And when I was looking at these, I found this, I Googled this, and Yeah, it seems to kind of match this one right here in the middle. It sort of have the same kind of shading. I could have picked better ones, I guess, if I spent more time, but I'm seeing these kinds of shapes, which these are all just indicative of how atoms are orbited by electrons. And so this doesn't mean this is a cloud of electrons. This, from my reading, means that it's a cloud of possibility of electrons. So whatever that means, it's interesting that that matches. I thought this was fascinating too because I was trying to make the RAV from the wrong side of the magnet, and I noticed that it had this very similar shape to cyclones. And so I thought I would just take a screenshot real quick. It's not a great screenshot, but you can see that it on the macro scale. I mean, I'm sorry, on the micro scale, this is a cyclone, and it's amazing. This is totally amazing how God's made creation where you can peer into the universe by experimenting with small things and to get you a look on the big things. All right, so just for the future, as per Nathan's good idea, I bought a piece of granite because granite is porous. Unfortunately, I bought the cheapest piece of granite and on Amazon, and it's so highly polished that it won't absorb water. So I'm going to rough it up, and then I'll do some granite um, ravs, and then I'm going to cut this salt rock into sheets and sand a really nice clean sheet, and then I want to see if I can what happens on this Himalayan salt to try to see what ravs do on that. This is what the granite looks like. It's kind of funny. I'm complaining about it because it came in really nice, but it's not the nice that I wanted. It said raw granite, and it is raw granite, but they polished the raw granite, so not too helpful. This ginormous piece of salt. Every time I go to the thrift store, they're selling these salt rock lamps. I guess they're a novelty, but you can get them for like $3 at the thrift store. So pretty cool stuff. All right, so this is the what I'm designing. It's going to be a meter to measure photons, and what it's going to do is I have these little 1 meter millimeter wide, a couple millimeters long cuts. This is one of those old CD drives where if you ever remember buying a pack of CDs on a spindle, and it always had this black one on top because it was like a protector so it wouldn't scratch anything. So I picked this up from because I collect everything garbage, not garbage, but anything that looks cool. So I'm cutting these slits here. I'm going to put some photodiodes at 120 degrees apart, and I'm going to call this the photon heart. And what I'm trying to do is get these photon diodes to pick up the photons of light, just to pick off strings or waveforms of light, and to give me a certain frequency pattern. And if I get that frequency pattern, I will know for sure, not 99% sure, but 100% sure that it's rotating. So I just needed this proof for me. So I'm building this thing. So here's the RAV below. Here's the disk above. Here are the photodiodes. This is kind of how I'm going to be constructing it. And the wave pattern I'm really hoping for is the top one. So I'm going to have 3 oscilloscope probes, one to each photo diode, and it's going to pick up light. And my hope is that it's going to have 3 different frequencies, waveforms, sorry, 3 different waveforms with different phases. There you go. If I have 3 different phases, then it's 100% rotating. If I get this, oh boy, I'm going to cry because it means it's just oscillating. Now, oscillations, it's still confined energy. I'm still going to investigate it. It still has potential, but I'm really hoping for this waveform. So hopefully I'll have the results if you guys are interested in my next presentation. And here's what those little photo diodes look like. They look like little TV screens. And I mark the cathode because they don't mark it. And there's the disc with the holes cut in it, and 3 resistors, 9-volt battery. I need the 9-volt battery to reverse bias these diodes. That way they'll be hypersensitive to the light. And therefore now I'll be able to take some really cool oscope readings based on these diodes because of how highly sensitive they are. They pick up light patterns, millionths of a second, billionths of a second. I mean, the frequency range is incredible when you reverse bias these little photodiodes. So if you're ever wanting to measure light, oh my goodness, or even just electromagnetic energy, I think these can pick it up. All right, what am I ending with here? I think this is the last slide. So this is a petri dish. I put a 60,000-volt power supply, PC power supply. Kind of a finale ending here because it's cool looking. And the higher I turn it up, the more it turns into that purple dance you saw. So that's when it turns purple and dancing around in one plasma, that's 60,000 volts. So you kind of see the difference, about 50,000, 40,000 volts. And it's fun to look at. Pretty cool stuff. And I think this concludes my presentation. Yeah, so let me see if I can get out of here without losing you. Stop sharing. And that concludes my presentation. Thank you guys for listening.
Yeah, I did that last one, Shawn. You were just showing where it sparks off between two plates and you see all the, dude, that's awesome. You see it in person.
Just put a glass petri dish in between two plates and it just dances like rain. It's pretty interesting.
So check it out. I took you took a flat plate and then I took a round one and I put it on my drill. And I put the one end of the electricity, one in here, and just turned on the drill, and it'll spray out in a pattern.
I saw that.
Same way.
I saw. I watched all your old plasma videos. I saw that. That's oh yeah, I got a good ideas from you. That's awesome.
Right on. Yeah, I don't think people remember me doing that stuff, man. It was a while back.
Yeah, yeah. Well, we're going on 3 years since we know each other, 2.5 years.
Yeah. Well, still, you got like 600 videos on your thing, man. Nobody look back, that hard sometimes.
It is, yeah, yeah. You're prolific in your output. I mean, I get tired seeing all your posts. You must be exhausted. I'm like, oh man, this guy's doing the hard work for a good channel. So what were your thoughts about the RAV? I can say it.
Dude, you got so many cool things in there. Are you okay with me talking about everything, Shawn? Because there's a lot here.
I love it. Yeah, I can just give my throat a rest here and pay attention.
Okay, so let's see if I still have it up. This picture here.
Oh yeah.
Okay. So this is what I was showing Shawn earlier right here. I want you to look at this electron ball right here. Okay, it just looks like a mirror image of this one down here. Here's what I want you to see, Shawn. I don't think you even saw this.
Sorry.
Look inside here. There's a ring. There is a center dot. These rings all correlate with the rings outside. So this inner one is the same as this outer one.
Mm-hmm.
This outer one is the same as this one right here. You have two independent frequencies right there. That's why you're picking up on your O-scope. You're picking up packets, so it goes like this, okay, in that shape. And then the other one goes right across from it. When you show the three patterns going together that you wanted, and I don't have that picture, you do? Okay, so check this out. When you take your oscilloscope, and I want you to zoom it out as far as you can.
You want me to find it?
No, it's okay. Just do it later on. I'm going to tell you something. And it goes to a video that I showed. Okay.
Okay. Mm-hmm.
You will literally see the pattern of resonance within it.
What?
Okay, this sounds strange, and so everybody tells me, "Hey, there's nothing there, Nathan? You're just seeing things." Okay.
Ooh, oh no. Okay.
No, but this is where it gets fun.
Awesome.
It builds out in a toroid every time you look at it. Wire around. Okay, electricity around the wire.
Yeah.
But as it does that, you see the resonance coming in packets. When you showed the 3 frequencies themselves,
Yeah.
it started to show diamond patterns in between them.
Oh, that sawtooth triangular wave you're talking about?
Yeah, so I'm gonna trip you out right now. Okay, we're gonna look at something
Okay.
because I could tell you why your oscilloscope does it now. Let me just find it.
Thanks for
You
all
know
the
what?
love in the chat, guys. You guys are awesome.
Okay. So we see your oscilloscope reading, right?
Hmm.
Let's back it off just a little bit.
Hmm.
You see the wave pattern inside of it?
Yeah, I do.
And now watch what I do. Now this is just my Tesla coil and resonance. Now this is what you were talking about when we talked about the sound wave, right? You
Yeah.
put that out, it goes up, it goes down. Well, the sound itself, when you build it out,
Hmm.
you see it right there.
Hmm.
That's out of resonance. Okay, which means you're only getting one side of it.
Yeah.
Now you start to see the resonance come in. By the way, I'm flipping the cap bank as you see this.
Okay.
Right there. You see the pattern behind it?
Yep. It's like a resonant ring. It's like a funnel. So
Now
those are
do
resonant rings.
you see the one on the left shows it in resonance. The one on the right shows distortion.
Right. I can
You're
see
in
that.
coherence and then
Mhm.
you're in distortion.
Yeah.
So when they build out, try to
Hmm.
find the right one for you here. There you go. Does that look familiar?
So it does. It looks like that sawtooth triangular wave. I mean, it looks like a thicker version of it, but it's definitely the shape is there, huh?
It's trying to show you a 3D image, but it's not supposed to show you in a 2D oscilloscope. It knows it's
Oh.
there. It
Mm,
doesn't know how to show you it's there.
yeah.
So this is what you're getting, but it gets better.
Hmm.
Let's see if I can't find it.
Okay.
Right there. You could see it. You see the
Oh wow.
diamonds?
Yeah.
All of what you're showing in there, what you're looking for is right there.
That's interesting.
It picks up
How
the
are you getting
background pattern.
how are you getting that? It's amazing.
All I did was just put it on my oscilloscope, and then, like I said, I zoomed it out. See, 99% of the people who own oscilloscopes are going to tell you that this is absolute gibberish. But
It got a pattern. I don't know if it's gibberish.
when you start to get patterns, you have to pay attention
Right, exactly.
because all resonance is patterns in nature.
Interesting.
So as soon as you flip to the cap bank on your Tesla coil, you start to get things start to happen.
Hmm.
It goes in and out of coherence,
Mm.
distortion, coherence, distortion, coherence. That's what resonance does.
Oh, do you think the flicker of the rab was doing that? Distortion and coherence?
Yes. That's
Interesting.
why you'll see it in just looks like something like a radio, and then it'll go into coherence. You'll start to see a pattern show up.
Right, right.
When you say, okay, I want to see these 3 colors right here on your picture you showed, right?
Yeah.
You're showing the diamonds on the inside exactly the same as I just showed you in a waveform.
Oh, that's interesting. It's
Yeah, it's
interesting how the
right.
frequencies look the same. I mean, they're different frequencies, but the shape, I
Well,
mean,
yeah,
that's not a coincidence, right?
no, because you're dealing in octaves. You're dealing in the
Makes sense.
sound,
Makes sense.
and everything builds out in that same way, whether it's a half, a quarter, whatever it is, a third, it's
Hmm.
all building out the same way. That's
Right.
why it's so important to understand what it's doing. You're dealing with the entire musical scale at this point. That's why it's tied into resonance so hard. That's why it's in string theory. That's why it's all together. It's showing you electrical theory, but it's also showing you the fundamentals of how science is done through the regular physics theory.
Yeah.
So one other one, let me see if I can't show you this real quick.
Okay.
So you pointed out the energy patterns in the other one, right? Oh, let me find it.
I'm gonna mute myself for a second here.
Yeah, yeah. Okay, this right here,
Sorry, I had to cough. I'm good.
not a problem. You see the black zones right there?
Yeah, wow. Did you screenshot that?
Yeah. So the black zones are null zones. So you'll notice that the energy propagating in the center and the energy on the outside are still connected, but the null zone makes it look like it's not there. So what's going on is the energy, it looks like it's going flat. It's pulling a DC flat line because it stops, it goes, and then it starts again. It will not propagate in the null zone.
Right, right. I've seen that many times.
Now it looks like a boson, but what it actually is a torus.
I
You
didn't
gotta,
think about it. Yeah. It
you
could
gotta,
very well be a null torus.
you gotta, and in the inside you have your dielectric field.
I gotta write this down. This is so good.
And because it's a torus, it's in the magnetic field.
I never saw that. It's totally a torus. Oh my goodness.
And then I want you to look at the energy here. See where my cursor is? See the lines of energy going out?
Yes.
They build out just like this. There's a
Yes.
point of insertion and they build out like this. Okay. They're going around and wrapping around the torus. Just like
Yeah.
that. Just like we see all the pictures. So everything that we're doing here, this is physics. This is exactly what they want to show you in every one of their details. But this is coming right out of it. Okay. Oh, it gets better than that because your null zones dictate where exactly everything pulls out. So let me bring out another one.
Okay.
And let me find it because you showed it to me.
Thanks. Thanks, Gerald. It's cool, man. We have different opinions, but no biggie. I respect your stuff, man. You're awesome. Anybody who has different theories about it, the RAV is totally cool. It's the only way we learn. So yeah, no, I appreciate your input, Gerald. You're a fringe scientist legend, man. I'm not gonna say anything other than thank you for your input.
Okay, hold on. Right here. Here it is. This is the one I wanted. This one right here, Shawn.
Okay. Oh yes.
Now, think about what I told you about the null zone. See, null zone don't build out just flat. They build out in geometry.
Which is fascinating.
Which is exactly where the black zone is in every single one of these.
Yeah, my goodness. I didn't see any of this.
This is where your null zone is. This is why the energy is different. It's crossing. It's going in spheres in certain instances. So it could build out in a sphere. It could build out in a flat, rotational zone. It could build out across from each other with different vectors. It literally is right here. You're while putting this on the side of it, you're building these things out. This is exactly what physics is saying.
I need to now photograph each one of these because I don't keep the plasma in the lower levels very long. I usually just get it up to the 30,000 volts and then start creating RAVs. taking it slow, now that you've shown me this, I'll look at the nulls, and then what I'll try to do is see how many of these I can match. So I think that would be a
Yes.
fun discussion if I can.
Oh, I've already seen a couple of them in there. You see,
Amazing.
hold on. I got another one to show you. It's like show and
Okay.
tell today. Give me a minute.
I'm looking at you on my iPad, so don't think I'm not looking at you.
Oh no, we're good. Oh, where is it? It's got to be here. It's like looking at a negative image. Let me find the right one.
Okay.
Things are scattered all over my thing every time I change monitors.
Oh, also, guys, I'm a little late in the chat. Thank you for all your kind words and your support. You guys are awesome. I wouldn't be here if it weren't for you guys. So thank you.
Okay, so check this out, Shawn.
Okay.
You got energy coming in.
Mhm.
You have a complete null zone, and then the energy comes out.
Where did you get this? Is this one of my videos?
This is on one that I did.
Okay.
Where's the energy in the black spot?
I don't know.
It's there, but it's building out without frequency.
Oh,
See, it's right there in the center. We see it building out. There's absolutely nothing until it builds out over here.
yeah. It's why is that? Is it a
It,
no ring?
it's building out as a sphere,
Oh.
as a null zone, which is telling you that
Mhm.
the energy is still there. You
Mhm.
are not able to contact the energy. You cannot see it.
Hmm.
It's the speed of light. It goes in one side, it stops, goes through what looks like a wormhole almost, and goes to the other side
Yeah.
and propagates to light.
Yeah.
But I don't
Exactly.
think it's a wormhole exactly. It could be, I mean, anything, just a flat line that goes over here on each one of them that just does it without frequency because it's so compressed.
Mm.
There's so much energy, it compresses, or so much compression around it, it comes out as a straight line. So you
Mm.
have no frequency, therefore you have no light. It's only until it can decompress that it comes back to a frequency.
Ah. What?
This is,
Forgive me for asking if I missed it. What is the setup in the light? Is because I miss it? With the lights
oh,
turned
I didn't show the setup in this one. It's
on?
sim- it's simply in the dark. When you do it in the dark and there's a light to the side of it, so you can get to
Oh,
see what you're doing right here. That's
yeah.
it.
Yep.
You
Incredible, man. That's all I can say.
well, that's why they get the speed of light right and wrong at the same time.
Mhm.
It moves at the speed of light going in. It compresses and then comes out as light again, but the speed in between is what they're measuring.
It's instantaneous in between?
Well, it depends on how you see your theory. Is it instantaneous, which I think it is, or is it the speed of light, which they talk about?
I mean,
How
I
long does it
believe
take the energy to get from one side to the other in a straight line?
I believe the one-way speed of light is instantaneous, and you can plug that into any formula of all physics, and it won't break. The reason why it won't break in physics is that the return trip of light has to be half the speed of light. So currently, we only know the two-way speed of light, which is 300,000 kilometers per second. If you say that light goes instantaneous in one direction, but when it comes back, it's 150,000 kilometers per second. If you then take the instantaneous and the 150,000 meters per second, kilometers per second, and average them, take the average, and you will get 300,000 kilometers per second. So if I believe the one way is instantaneous, the other way is half of light, all math works. And what's cool about that is when they say, "Oh, that that galaxy's a billion light years away. We won't see its light until a billion years later. No, because it's instantaneous one way, we're seeing the universe as it is, not what it was, but as it is. And that's a theory I've been working on for a long time. And there's a really popular science channel on YouTube, Astrom. I
Okay.
forget.
I know what you're
And
talking about.
actually, and he does a video on it and says, "Yeah, guys, we don't know the one-way speed of light," and he proves my theory. So yeah, so I like that because now that the one-way speed of light that supports what you're saying. That null zone is an instantaneous zone.
Yeah, you touch it with one side, then it comes out the other.
Yeah.
It's amazing because you're what you're doing is proving everything of physics out and showing the work. You're showing what the math actually says. So
Yeah.
I got a
Real quick,
video to show you. I just
yeah,
want to
real
trip
quick
you
on
out.
that though. What I'm hearing, and I'm agreeing, but I just want to put it in my own words. What we're seeing is a physical phenomenon, a physical model of that which has only been existing in the mathematical imagination, but nothing visible. I didn't word that very well. A lot of what they try to say is a lot of math, and then now what you're saying is Arab translates that math into a lot of their predictions. Maybe that's better. Thanks, Ian. You're awesome too, man.
Oh, all right. You ready to be tripped out a little bit, Shawn?
Yeah, let's get tripped out.
Okay, so let me bring it up real quick. This is kind of one of those things that goes on behind the scenes,
Mm-hmm.
and you really don't know it until you see it.
Wrong idea about how our solar system actually moves. We were taught in school that the
Oh
planets
yeah,
orbit the sun while it stays perfectly still, but that's not true. In reality, the sun is hurtling through space at an astonishing speed of 828,000 kilometers per hour. It's not stationary at all. Instead, it orbits the center of the Milky Way galaxy, just like Earth orbits the sun. That full
Amazing.
cosmic journey takes about 225 to 250 million years to complete and is known as a galactic year. But here's the wildest part. Since the sun is moving, the planets don't just orbit in neat, flat circles. They actually spiral behind it in a helical motion, forming
Incredible.
a vortex as we all travel together through the galaxy. So right now, as you're sitting there, you're actually rocketing through space at an unimaginable speed without even realizing
Wow.
it. It's like we're all on a galactic spaceship. Crazy, right?
Okay,
Crazy.
see if I can find it real quick for you.
So you're
That
you're
full
saying that in
cosmic
the
journey
middle of
takes about
Milky Way's
225.
Arab.
Just watch. See this? That little green line?
That's the triangle wave.
That's string theory.
What?
When they
I
start
know
showing this,
string
when
theory.
they start showing the strings, making all the different shapes,
Mhm.
and they start showing it, that's string theory right there.
Interesting.
It doesn't seem like it, right? But it is.
Yeah.
They're making shapes. The problem is when they show the string theory, they show it in 2 dimensions, not 3.
It's hard to not show it. That's why this video is doing well. That right there, that green line is a galactic year. It doesn't look like a galactic year to me. You would think a galactic year would be, what we're used to, circle.
What?
This thing is.
Think about this. See the
Mhm.
little dot where it says we are?
Mhm.
These are the little tendrils that come off of it. What if the tendril next to it, we want to get to the galaxy over there?
Mhm. Yeah.
All we need is in this area that looks dead is the
Mhm.
Einstein-Rosen bridge. Okay.
Yeah, I wrote that down.
Now the space is much different. You didn't have to bend space. Space is already bent. You don't need to bend it. to get to that light. It's
Okay.
already bent. You just have to create the bridge.
How do you create the bridge, or what? Actually, what is the bridge made of first?
Well, it's just opening up an area that you can go through without
Okay.
any inertia in it, so you can accelerate as fast as you possibly can.
Okay.
So, but it pulls you in and throws you out. It
Interesting.
doesn't work for you. You don't have to do it, because it's working between two zones. So you don't have to create the energy to make it work to throw you through it. You have to create the energy to open it, and that's it. So
Okay.
yeah, it's like a misunderstanding of the true understanding of physics. Is what's going on when they say they're bending space.
Mm-hmm.
Space is already bent. We're in multi-dimensional fields, okay?
Mm-hmm.
Because you got to understand this. We're in a field here. So we have vector direction in each way, okay? You have XY axis plus a Z. Now you have 4 fields on it, okay, from it, which give you 4 extra vector directional spots. But
Mm-hmm.
since we're in a spot where we're moving around a toroid like this and flowing in space, just like energy around a wire, now you
Yeah.
have a vector direction from that spot that we're going around in that toroid in there. You pick
Okay.
up another vector direction based on the toroid. Do you see
Mhm.
how they start to add up? Now you
Yeah.
got to remember where we are inside of the actual cosmos, where the set, or excuse me, inside the galaxy, where the
Mhm.
center of the galaxy itself is throwing off vector directions as well. So
Yeah.
when you start adding them up, string theory makes perfect sense in exactly how many dimensions it tells you it is, because
Mhm.
they're not accounting for everything being geometry. They still try to make it algebra. It does not equal each other. It is
What about?
based on rotations.
I totally buy the geometry notion, because I think they're missing out. You just proved the geometry with that video we saw where nothing's moving on a flat plane. We're all flying, hurling through space in a helical form, which is
Mhm.
interesting because DNA is a helical form. So the form which life depends on is the same shape as everything moving through the universe. Um, but just trying to save this here.
I want to
So
show. I want to show you one more thing. I showed you this earlier, Shawn. I showed it to Joe.
okay,
Do we travel through space this way, where you see the sun here, okay, and then
yeah,
everything's swirling around, just like the video showed, right?
yeah,
Or are we hurtling through space like this?
that's the question. I
So
mean,
here's
yeah,
the thing: if we're going this way,
hmm
then everything that's an asteroid, a comet, or anything else comes out in this direction. Okay,
okay, hmm
it has to. So what happens when we're rotating this way? Then everything comes through and back out just like this. So it says that we're spinning this way through the cosmos. Okay. Not hurtling this way, like they said, but like this, because of things that come by us in every direction. They're coming by us like this on our what looks like a flat plane.
So one is having the polar regions facing toward in the direction of, I guess I'll just call it reality. And then what you're proposing is that it's the hemisphere that leads at the flow of reality. Is that
Mhm.
what you're saying?
Just like, I don't want to say this, just like a Tesla turbine does. As the blade spins, it
Hmm
pulls you into a Mach. Okay. It isn't pushing against the Mach wall, it's pulling you in. That means it's increasing the speed as it goes in rotation. Okay.
hmm
That's why it's that way. Because when you do it the other way, you're pushing against the Mach wall. This way pushes against the Mach wall. It creates resistance in front of it. Therefore, it slows it down.
Mm,
In
yeah.
this direction, as it spins, it comes over the top and pulls the
Yeah.
energy in and makes it go
Yeah.
faster.
That geometry makes total sense the way you just explained it. Total sense. Because everything is rotating and spinning. And how is it? It's because what's coming at us is rotating us. So what's coming at us that's causing
Well,
us to rotate?
whatever's left behind from the last solar system that ejected it,
Mm,
whatever's in front of us in the line as it builds out in a tendril, it's
mhm.
throwing stuff at our planet.
Interesting.
It's throwing stuff at our solar system. That's all that's going on. It dislodged it from theirs, goes into ours. So
Interesting.
I want to say thank you to Ulysses, man. Thank you very much, brother. Thank you for taking care of me, man. I appreciate it.
You are awesome, Ulysses. You are awesome. Thank you. I
So
appreciate it.
just so you understand, Shawn, I told you this before.
Hmm.
What you're doing is proving out the theory of resonance being the key factor in everything that we do.
I appreciate that. It blows my mind to think that everywhere I've looked, 'cause I've been trying to prove this thing wrong, and I don't believe it's 100% ball lightning. I don't believe it's 100% plasmoid. I think it just has a lot of similarities. But what surprises me is it's self-organizing. It surprises me that it confines all energy. It surprises me that it has frequency, and it's the resonant frequency, and it's not the resonant frequency of a Tesla coil or resonant frequency. It's not a mechanical frequency either. It's a resonant frequency of a spinning ball of electrons, and they say ions, which I believe, and ions would just be nitrogen, oxygen. But when it's white, I really think it's pure electrons. The more I study this phenomenon, the whiter it is, the more current it has. Is an indicator of its color, but also it's an indicator of its density. So if you have this purple all splattered over everything, it's not dense. But when it brings it into density, um, then it becomes whiter and whiter, having all the, I guess, colors of the spectrum in one. Um, I tried wearing a welding helmet when it came on, um, but I can't, I'm blind as a bat. I need a welding helmet with a microscope on the end of it. So I'm going to figure out how to dig into that visually. Now the harp, uh, oh boy, the I had a word for it. My instrument I'm building. It'll come to me. Oh my goodness, it was such a good idea. Uh, I'm saying the quiet part out loud. Uh-oh.
It's all right.
I mean, yeah, I guess.
Well, okay, so Joe and I had a discussion about this. It'd be interesting to get your take on it. Okay, and I talked to you a little bit about it. When you're building this thing out, right? And you
Mhm.
want to talk about a sun and how it builds out. And our solar system's formed by planets being sucked together by a bunch of little asteroids, or are they building out as planets? Okay.
Mhm.
Goes to the plasma effect. When you want to take hydrogen, right? And
Mhm.
that's basically what you're doing is you're making a hydrogen inside of it. Okay.
Okay.
You're splitting out, you're making hydrogen inside. It takes on a magnetic field that pulls it in, holds in, and adds electrical fields on the outside. What we're not seeing and realizing that space is holding it in itself. Okay.
Okay.
The space is creating the outside field from it because it's stopping it. It doesn't let it propagate any further. Okay.
Mm.
But what you do is it builds out and then it tries to combine and go into helium. Then it
Mm.
has to go back in and break down. Okay. It
Mhm.
breaks down because there's ionization. Ionization breaks down molecule chains or atoms, however you want to see it. Okay. Goes in
Mhm.
there and breaks it down and then it resets it and it puts it back out. The reason they don't have a tank of hydrogen on there on the sun, okay, is
Mhm.
because it couldn't have it. So it has to recycle the stuff itself every single time. It has to recycle it in some way. Why does it do it? Or how does it do it? It builds it out, combines with something, then it goes back and breaks apart and goes back in. But what happens is when you get into high density plasma is it'll start spitting it out. It starts spitting it out. This is the energy to matter conversion. You're literally taking high voltage energy, converting it into matter in the sun. It's coming out as plasma. It forms a planet. Okay. If that
Okay.
planet has a resonance frequency inside of it and caverns as it's done, it'll now propagate and begin energy, and it'll build out your entire solar system. You don't need collisions. You don't need anything else. The plasma itself, that conversion is the understanding of how to do it.
How does I mean, that totally makes sense. It boggles the mind to think that the spinning things in our galaxy and the spinning of our galaxy, that there are resonant frequencies that are all around us. I mean, what is the speed of the Milky Way galaxy? I don't know, but I can tell you it's its resonant frequency. What's the speed of the sun's rotation? I don't know, but its frequency is resonant. I mean, I've never thought about the world that way or the universe that way. Not until we talked. I mean, I'm telling you, and I'm just seeing it everywhere, patterns, and I I love, how artistic creation is. I love the patterns. What is Joe saying here? You're
Oh,
using
I wish Joe was in the conversation because he would tell you how it ionizes the hydrogen and it creates negative and positive to it.
Oh, is he jumping on soon or?
No, I don't know that he is, but he's got the right idea of how it's going on. Let's see. Charged ionized hydrogen by the cathode reaction formed the ceramic, and using the God, I'm a terrible reader.
Anodic plasma.
Anodic plasma to rip the valence of the electron off the hydrogen.
Mm,
So that's one of your guys' talks. I see fields, you guys see electrons and how they work. So
yeah, I mean, I kind of believe both, but it's both models help me understand. So when I was going through the different experiments with the RAV, so one of the things I didn't mention was that each ring or each layer of the RAV has a different temperature, and because of that, and it needs that temperature because there needs to be hard lines between each ring. It's not just one spinning ball plasma. They call it sheaths. It's kind of hard to say for me. Let's say we'll say layers. And so these layers, oh my goodness, they have different rotations, they have different temperatures, and if they have different temperatures, then they have different energies. And the middle of it, in studying it and even reaching out to AI to figure it out, it's up to 50,000 degrees in the core. I thought it would be hotter, but I guess 50,000 degrees Fahrenheit is plenty hot. I mean, what is it? Something like 3,000 degrees, but pretty much melts everything, right?
let me, I got to do this to you, Shawn.
Okay.
They build out at different temperatures because it's scalar. Energy, frequency, temperature is scalar. It builds into the flat zone in the black area between planets because Tom Bearden already told you it did. It goes into that straight line that builds back out into scalar anytime it hits mass. It's the lack of mass which gets rid of the frequency inside of it. It's the mass that brings out the frequency. It's what propagates light. So in scalar, that's exactly how you're working. Temperature difference at a distance. So every layer has a different frequency. Every
Mm.
layer has a different temperature. It's scalar to a T.
Interesting. Yeah, I don't know a lot about scalar, so I'm pretty much in my investigation. I'm finding that it's confirming the properties of scalar. I mean, because I'm telling you things that you already know, but I didn't know that it was scalar. And is it scalar or scalar?
Well, I would imagine it's scalar. I just
Scalar.
call it scalar. I don't know. Probably a reading indeficiency on my part.
Oh, I've been saying scalar too. No, it's your California accent. We tend to drag out vowels differently.
By the
Exactly.
way,
Uh-huh.
oh, sorry. Go ahead if you want to read Joe's comment.
Okay, exactly. It's all the separation of the cathode reaction that allows for dual charge of the hydrogen. It breaks under the positive polarity arc and separates the ionized atom from the electron, furthering the plasma density and causing an offset charge differential. Woo!
He knows.
He knows what's going on.
But by the way, your clay is acting as a one-way diode.
I believe that. I really do. It's a nonlinear material, and I think anything nonlinear is a diode. Scalar echo mapping. So what do we got? So you've already blown my mind 10 times. um, I mean, any questions in the chat? I'm getting some good comments here. Some of the future experiments, different materials. So what stuck out to you in the presentation the most, Nathan, tonight? What stuck out to you the most?
Is the light. The camera gave you your answer before you can even figure it out in any
The
other way.
refraction. Yeah, that's fascinating. That's
It,
so
it,
fascinating.
it's funny because they always have a mirror when it comes to how to understand stuff in like Egypt or
Mhm.
anything like that. I've always said the Egyptian cross, you put the mirror in it and you're gonna find your infinity, and you're gonna find your vortexes, and you're gonna find your plane right here. Okay,
Mhm.
every single one of them is actually perfect in the understanding of this.
Mhm.
Okay, we see it as the figure eight, but it's actually like we just talked about. It's the torus.
Right, right.
It,
Incredible.
it's crazy how it works out. I mean, the other side propagates the energy out. There's a couple different ways to see it, I guess, but the
Yeah,
mirror itself in the camera was the most outstanding thing because it was showing you inside of the actual RAV.
I know.
The
Incredible.
rings inside of it on that mirror, it was just showing you what's inside of it. I don't want to say this. I don't know if it diffused the light enough so that you can see the real image. It removed enough of the light. I don't know if I got the term right. Removed enough of the light so the real image shined through. But
Mhm.
because it was a reflection of it, you got to see all of it.
Yeah.
And it
Incredible.
couldn't build out any other way because it showed you the positions of both spots.
It
So it
did.
was 100% accurate to what was going on.
It's incredible because this is more accurate than my diagram of layers. It's like it was looking into the heart of it. Um, wow, incredible.
Oh, the stack plates. Joe likes the stack plates. So check this out. You did energy, null zone, energy, null zone, energy
Oh,
in your stack plates.
oh, I was
The
going to ask
path of
you.
least resistance.
Sorry, my wife's saying goodbye.
Oh,
Love you too, baby. Um, see, stack plate center and the one dark point on the anode side around a dark point in the center. It seems inbreeding the second and third plate. That's a scientific term, inbreeding. um, so I was just trying to show you the underside of the clay, but I guess it exhibits a different phenomenon. The stacked plates exhibits this phenomenon. It's my mind is being blown. I'm telling you, Nathan. I have so much to go back to and look at. It's like, oh my goodness. It's like you guys are taking off. I don't know. I have the wrong prescription glasses, and you guys keep giving me a better pair, and I can see a little bit more. It's like,
Oh, Sean, it gets better. When you go out to space, space is like a vacuum chamber.
mhm.
So what happens to this in a vacuum chamber? Well, it's very much predictable. We see just basically plasma in a vacuum. It pulls
Mhm.
out and stretches it apart. So instead of it being a dense field, it becomes a light field, right? Well, it's going to show the exact same thing as soon as you get into a vacuum chamber. So you want to change the size of it, you have to change the vacuum quality of it. How much vacuum does it have now? How much more does it need? You want to take this into another theory, and you want to go into, let's just go into making a, oh man, what do they call it? Fusion reactor. Or, yeah, fusion. All you have to do is increase the amount of hydrogen that goes in to propagate a bigger field to give you more energy. So you need that water to split more. See,
Mm,
they have the wrong idea. You don't hold in this thing with magnetism.
mm.
That's what the sun already told you that. You hold it in with the space around it. Okay?
So
You
the
have,
ether containing it.
yeah, that's the only way to contain it. Magnetism is when they do that on the outside, that's
Mhm.
where all their money's wasted because you didn't need it. You see,
Mm,
you needed the amplification of the Earth's energy already to hold it in. That's just what the thing is telling you in space. It builds out to a certain value and it
mhm,
stops. But that in itself is a field. See, that in itself is a zone. Right there is a zone. They're not counting it as a zone. They don't
mm.
see it the way they're supposed to see it. They think they have to
Yeah.
hold it in. They don't. It's already self-zoned.
Mm.
So
Interesting.
that there goes half of their energy bill right there. That's wasted. But then here comes the hard part. How do you keep that energy inside without it going everywhere?
Yeah. I
Because
mean,
you see it constantly building out like this in a scalar field. How do you contain that?
well, you saw that the quartz crystal guided it where it wanted to go based on its geometry. You saw that, and the electrons just slip smoothly over the quartz. I mean, it's not this high resistance property. I mean, the quartz just sent the plasma where it wanted it. I just thought that was an interesting property. I don't know if you noticed it too as well.
Mm. Huh. I don't know what that was about. Okay.
Somebody shot some UAPs.
Dude, you have what will end up being the precursor to probably nuclear fission or fusion. Sorry.
It's weird that you say that because that's the first thing that came to mind when I discovered that it was self-organizing. The main component that prevents fusion is they cannot create the heat, the plasma, hot enough for fusion. So they use these high-powered magnets to hold the plasma together. And they think that if they can just keep using more magnetism to hold it together, then they'll get the right temperature for fusion. And so what we're seeing with the RAV is that plasma is self-organizing,
Mm.
and it's self-organizing in a way that's confined and contained, which means that it's almost like it's doing on a small scale. Um, Honestly, hey crypto, awesome to see you. Um, it's great. It's like a small scale of what they're trying to do on the large scale. And I mean, we're spitballing, we're having fun. I think the evidence will show that we're probably heading in the right direction. But that blows me away that it's doing something that people aren't that are trying to do a very complicated way.
Yeah. Because they're not understanding it's the size of something that builds out the heat. They're not building something the size of the sun. You're not going to get the heat level. You have to put it down to what you're building. So when you build in the very small where you can't see it, or you build out in the molecule, or you build out in the atom, or you build out the sun, everything is based on the size that you build it, which is based on the temperature because scalar told you it was. It told you that it built out by the temperature and distance on every single one by the frequency. So when you're talking in a very, very macroscopic scale, you're talking about the frequency being so close together, you don't notice its frequency itself. Therefore, all you had to do is adjust it a little bit, and you're in those small scales, but then it starts to go to the bigger scales. You'll never match the energy of the sun because you don't have the size. But it doesn't mean you need that much energy.
No.
I mean, think about it. We think of energy the wrong way. You think you need a ton of it. You don't. We're in inefficient systems. They don't resonate together. You can cut off half your energy bill just by resonating the motor to the frequency that's going on the pole. There goes half your energy bill. I mean, do you need that much? They're not understanding. Yeah. So it all starts with the resonance. It's what makes it self-organizing is the resonance.
Those two things happening makes it special, I believe.
Yes.
Because, I mean, you can put a lot of circuitry and a lot of complexity to get a spinning ball of plasma. So there's not a lot of complexity going in. You saw me. I'm just goofing around with some water and clay, and it's geometry that's really, again, it's electricity, water, and clay. What else is there? Thank you, Yanni. There's some good comments here.
Well, you ionize the water. You know that, right? You had to know that. You ionize the water.
I know that it's ionized water. What surprised me was that the water contains the electric field. It compresses the electric field. That I didn't understand until I researched it. I didn't know water could compress and confine. I mean, you think it just spreads out like steam, but not when it's superheated and vaporized. It's being vaporized. It's not being heated because you see no trace of it. Nothing. It just goes right into the plasma. The plasma eats water and minerals. That's what the plasma lives off of. And I put my plasma on a diet because it was looking kind of thick around the midsection, but my jokes are awful. I cannot tell a good joke. I can't. It's so sad you can only laugh at me.
I don't think so.
You're kind. Yanni says, my view is plasma becomes a fluid conductor. Magnetic field, just like a motor generator, curving into whatever based on the influence. Lorentz force does that. Dope says the heat is gonna come from the density and the compression, so long as the equilibrium can be managed. I'm really in that thinking, Joe. It's about the density. I think if you can achieve the density, I think you can achieve the heat. But getting the density of the sun, that's a whole nother story. So maybe you need the size of the sun to get the density. But I agree with Nathan. I don't think you need the density of the sun. I mean, not to make a rav. Deadfish says, I never filled a MUFON report out in my life. Then I will fill out one for burning a crystal UFO. Okay, that's off topic there. Thanks for sharing, though. Elijah Tech says, if a plasma is self-organizing, is the Holy Spirit consciousness ether living? Well, as a biblical question, in all of Scripture, Holy Spirit's referred to with a pronoun of he. So I've never heard of electricity being a he or a she. I think Holy Spirit's a person. Now, are there parallels, I guess, to plasma and the spirit? Well, the Greek word for spirit is breath, it's air. And so maybe air being ionized as a parallel. That's a good question.
They
Interesting question.
it's like they drew a plus signal and a minus signal, didn't they? For when they said men and women.
Yeah,
It's like they were telling us something more, or hey, there's an arrow and it goes out, buddy. You know what I mean?
yeah, that's true.
That's
Yanni says
funny.
perfect understanding. Thank you. Unless you're referring to Elijah, sorry.
Oh, that's hilarious.
Do you mind if I skip more comments?
Dude,
Yes?
that okay. So hold on real quick.
Okay.
Uh your negative is your magnetic, which is ionized, which is pulled into the anode.
Hmm.
Okay, so the cathode pulls into the anode, forms the bubble. It
Okay.
forms your magnetic field inside of it by doing it this way. The electric field stays over it. As long as the electric field is running, the experiment stays. As soon as this one collapses, this one collapses. The moment that it goes is it pulls through that clay,
Hmm.
boom, comes out, boom, right in there. The other one covers it immediately. Okay,
Yeah.
you can't see the timing, it's so fast. And then you see them rotating, it shows it right in the camera.
Yeah.
As soon as you see that mirrored camera image, you saw it. And it is telling you what's in there.
It's mind blowing. Just every time you say it, it blows my mind.
Well,
I
you
mean,
got
I
to
can't
remember,
argue.
you're putting off the side of the voltage side of it. The other side's magnetic. So what happens when you spin voltage? As soon as you
Creates a
spin,
magnetic,
you get a magnetic field.
right?
Yeah, but that's exactly why it's so self-building. You're
Mm.
only putting out the electric field on that side. So as it initializes the magnetic field coming this way, it
Mhm.
keeps going, okay? Because the magnetic field doesn't dissipate out, it stays in there because the
Yeah,
electricity itself is building the magnetic field, which
right.
then builds out the other field outside of it, which is all of your electric field, which means that you're only dealing with two factors here. You got
Mhm.
your magnetic field and you got your dielectric field. Toymaker was right.
Yeah, I always refer to as electric field because dielectric's always associated with insulators and capacitors, whereas an electric field is more the generic. When you have a magnetic field moving, you'll get an electric field. If you have electric field moving, you get a magnetic field. I don't like the word electromagnetism. I hate that word. I want to say either magnetism or electric field. Yes, they are intertwined. Yes, they're perpendicular to each other. You can't really have one without the other if they're moving. But I don't like saying it because then everything's electromagnetism and you get lost, right? Oh, that flashlight, electromagnetism. Oh, look at the sun, electromagnetism. No, 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 no.
I hate that too.
Yeah, just a preference. I mean, if you like it, I'm not down on you, but it's just I don't know, pet peeve, I guess. I'm sorry. So you were saying, so you have the electric field, the magnetic
No,
field,
but there's the same. They're two sides of the same scale.
same scale.
So think about it like this: you have a scale, okay,
Mhm.
and just like in DC, like I tell you all the time, once you raise the frequency, you raise the amount of dielectric. As soon as you lower the frequency, you raise the amount of magnetic. They're the
Mm,
same thing on a scale. It's just one side versus the other. One side is heavy magnetics, one side is heavy, electric or dielectric, however you want to say it. And all you're doing is changing the frequency to change between both.
so you do this a lot, and it helps me understand, I guess, helps people think in a different way. But when you have, let's say, too much current in a wire, it creates heat. You'll always say, no, 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 no. There's heat, and then it has all of these other effects. So you sort of look at it from the different perspective, and I feel like you're kind of doing that again. Um, and I lost my train of thought. I'm so sorry. Can you re-say what you just said? Because I
We're,
have
yeah, we're doing it again because the heat builds out as scalar. We're okay. Here's the wire. We're going around the wire, but we're not just going around the wire. We're going in and out of around the wire. So if I were to put this in front of you in 2D, okay, what would I show you? I would show you string theory. Why? Because it builds out like this. Okay, it would look like just like round things around a round surface, right? That's what it would look like. But then after that, it would build out in double. So instead of 4 vectors, I would have 8 vectors on the next one, right? Now, how does that coalesce with what we're doing? Because everything is energy around a wire. Everything is going around a toroid. Well, when it does that, it changes how you see everything. It builds in, it builds out, it builds in, it builds out as it goes around the toroid. So they look like different things, but all you're doing is changing the frequency between them as you go.
Interesting. Jarvis has an experiment that he sent me, where it talks about building these toroids within toroids, and he calls it the Ghostbuster coil. And it's on my list to build, but it sort of seems like what you're talking about here, toroids within toroids, and these toroids have frequencies, and it's just mind blowing. I don't know. You just keep thinking because it makes sense, but then I've thought so differently for so long. It's still kind of getting stuck in my head, because I'm trying to plant words on it that we kind of don't have sometimes for what you're saying.
Well, that's why string theory is resonance. That's why they don't understand it, because they don't understand resonance properly. Now, how they understand it the way I'm trying to tell it, then they'd have no problem finding everything that you found in your RAVs, that I found in my coils. Every single phenomenon that goes on proves out string theory. That's why it's closest to the theory of everything, because they don't know how to see it properly. They see everything in 2 dimensions. They're not seeing it in 3. As soon as you add the 3rd dimension, it all starts to make sense. You're going, well, why didn't we see that before? Because physics themselves only likes 2 dimensions. Because in an algebraic equation, it has to build out to equal each other. Therefore, it can only have 2 dimensions. Okay? They say there's a z-axis. They never use the z-axis. Okay?
Okay.
When you build it out in y1, y2, t1, t2, you're not giving it dimension. I'm sorry. It just doesn't. They're not using geometry. They're using trigonometry, which is just algebra. Okay? They're literally not using geometry.
What about calculus? What are your thoughts on calculus?
It's
A
all
lot
the
of
same,
physics is calculus.
a lot of it's a lot of same thing. If it equals each other in any way, it's just fancy algebra. But algebra is a balancing equation. So when you see, okay, I got to flip this fraction upside down in order to multiply it out to get rid of all the different letters that are in it. That's what they're doing. Okay, so why? Because it has to equal each other. No matter what they do, it has to equal each other. And they say, well, we add spin theory, we add all these different theories. Yeah, but you didn't add the correct math. There's no radius in there. Okay, so there's none of the correct math that goes along with it.
Right.
I mean, what was that name of that guy that came out with the right math that does geometry?
The right math is geometry.
He was using geometry to prove everything to, not Socrates, but what was his name?
Plato?
No.
There's another guy, Plato, Socrates. There's a third guy. Oh my goodness.
But the math is named after him.
Oh, Euclidean geometry, Euclidean or Pythagorean?
Pythagoras theorem.
Pythagoras. Yes. Oh, good job, Eric. Eric got it.
Yeah, that's why we were not on it.
Pythagoras.
we need to start using that. Well,
A squared plus B squared equals C squared.
you
That's a
start using.
powerful equation. That's a powerful equation.
Yeah, well, they need to start using it.
Interesting. Euclid was a guy too. It's Euclidean geometry. So we use Euclidean geometry. We use I can't say that name.
Pythagoras.
Thank you, Pythagoras. Say that 10 times. Everybody's saying Pythagoras, but they're spelling it differently. Just kidding.
I would be
They are.
even worse at it. Yeah. Power of triangles. Well, think about it.
Interesting.
He's right in the fact that why does every pyramid do weird stuff? Every time you do it, it's like building a primary for the coil that you did. Why is it always weird? Why do they always have weird phenomena going around them? Because there's something special about the way it builds out, because it's one of nature's natural geometries.
That's, I don't think enough stock's put in that. I think that people think, oh, it's esoteric. Oh, it's metaphysics. Oh, it's, moonbeams and hippies, and they don't take it seriously. And I think they miss out. Also, too, science is very faddish right now. Whatever's in style, whatever is the fad, and they just miss huge gaps. They just all march in one direction. They're like a river. They just march in one direction and another direction, and all the uncovered territory in between the rivers is where we're at.
Yeah.
It's where we are discovering and looking at, because we're not being faddish. We're looking at what we see and saying what we see. I mean, and you have an intuition for plasma. I've noticed that.
Just think about it, Shawn. Your RAV is showing how the solar system is building out. My coils are showing you how that we get into scalar and how those things work out, and then how we get null zones in the center of planets. Okay, and then the null zone builds out. You know why the magnetic field's weak is because it's built out by the electrical field that's inside, which happens when the node hits the center of the planet, and it starts to resonate in different patterns. Okay, then it starts to set off everything else that's in the same frequency of it, because you're creating resonance frequency inside of it. And then it sets off the crystal, and then you start building out the energy, because the crystal itself builds out energy because it's compressed in a field. It's not that hard to figure out. It's just we're showing the physical work to show it. There's the difference.
Yeah.
They already came up with the science. We don't need to rebuild it. We just need them to see the parts of it where, hey, this is your experiment. Now you can rewrite it. You know what I mean?
Yeah.
Get it in your lab, see it, get the fine details of it, and rewrite it.
Right.
That's it. Just cut off the crust, and you know what I mean? Let's go.
Yeah. No, get with it. No, I agree. So what do you think then is the future of the RAV? I mean, my goal was to see if I can peel off a little of that energy that it's pulling in from around the space around it.
Ooh, there you go. Which you're gonna have. Oh, look at you go. Okay. You know you light up a light bulb next to it, right? As it builds out. There's no question it does it. You did it in a little tube next to it, which is they're harder to light up than a regular fluorescent.
But the fluorescent always light up to plasma. Always. But this one doesn't when the RAV is silent.
Really?
Nothing around it reacts to it when it's silent.
So is it a dead zone then?
I mean, it acts like one because, I mean, of course it gives light and heat, and energy goes in and that's it. There's nothing out. And that's what's been so strange about it, because if I'm going to extract any energy off this swirling ball, it needs to be giving out something. It's just not. It only pulls in. That's why it's silent. You hear it go silent every time. That's
Okay.
insane.
At what distances? See, here's the thing.
Hmm.
Is it further out? Would you get more energy from it? Okay.
I haven't tried that. I haven't tried further out.
And then Joe says it's compressed, so the energy is forcing itself inward. Therefore, it's not propagating outward. You're in an impulse, like, you know what I mean? Like, instead of an explosion, like everybody thinks, you're in an impulse in the center of it.
Yeah, it's so balanced. It doesn't. It eats a little clay. It eats a little water. And it needs a steady flow of electrons, and so it eats some electrons.
You're building out. Oh my God! You're
Early
building out
Leonard.
weak nuclear force to a strong nuclear force. Therefore, the weak nuclear force fits on the outside now. It creates the null zone. It creates a space in between planets. It's the darkness. It's creating the area where you can't get to the energy. You can't find the energy because it's compressed. It's remember what we said about the scalar? It's compressed. Now,
Yeah.
find the resonance frequency and put that into a coil. Whatever the frequency is, wind a coil to that frequency.
Right.
I guarantee you a light will light up next to it. Why? Because that's how scalar works.
I got to write this down. This is so good. I'm writing it down.
You man, that's awesome.
What's that?
Think about that. You're resonating at a certain frequency and you know the frequency, therefore you can wind it in a coil just like a string, and it'll turn itself, it'll pluck itself. Your harp is working just fine.
Yeah, if I can remember the name of it. The harp. The heart meter. I'm just drawing out a model here because I'm going to be trying to pluck some strings here.
Oh, you got it all right.
It's just amazing.
If you find out what the frequencies are of each layer, I bet you if you put those into guitar strings, it'll play itself.
Yeah, I'm gonna be doing a lot testing that hypothesis. Hopefully it becomes a theory that's workable, because it sounds like it. The only thing I could say, so it doesn't have any output other than light. It has a squishy magnetic field, but it's contained. It's not. It's holding it in. It has a contained ionized and gases. I'm just thinking. Let's see. Dope is saying, don't forget about the lightning effect.
Oh,
There is but cold could be better inward and outward vectoring from anode to the ionized hydrogen in the ceramic.
okay. So the ground has water during the storm. You're getting the lightning to pull out of the ground. Okay. So why would it make sense that you would have one of these like you showed on your other experiments, where there would be one at the very end of the lightning, that, you know, the energy that you put out there, and it has this little ball at the end. And we're talking about, could it always build these? Well, if it does, it means that the side from the ground pulled up. So now think about that. Your lightning. Now let's look at that little cylinder you put next to it with the light. It creates a ball. It pulls the energy from the ground. and then it propagates the energy to the top. You're literally building these things out every time you do lightning. It's a natural phenomenon.
Yeah, and I thought about that because a lot of people talk about the ball lightning phenomenon in lightning storms, but it's very rare. And I could imagine that. You need a certain voltage, you need a certain minerals, you need a certain amount of water. But because we're always zapping minerals and water all the time, you can get a RAV. That's my opinion. And because RAVs are pretty interesting, maybe people are seeing those on a huge scale, on a massive scale.
What if
Elijah Tech has something real quick. So
Go
Elijah
ahead.
Tech says, like slow lightning buildup, right hand rule. If you feel safe, I've got shocked from something that didn't shock me before. Environment is unknown factor. Isolate hard. Yeah,
He's right.
yeah, he's right. Daniel says ball lightning isn't so rare in Mississippi and Florida regions. Yeah, it's funny because every time I read about it, it's so inconsistent. And then it's also kind of demonized as sort of like seeing Bigfoot or something. So people are afraid to say that they see it. And I'm not saying mine is. I'm just saying is that it has characteristics of lightning, because right, electricity, water, and dirt.
Yeah. Well, you got compression, you got a field below us, you got a field above us. All
Right.
building out the same way. We're not telling any tales out of school here.
Yeah. Right. Thank you, Yanni. Photon harp. Oh my goodness. I'm going to build a photon harp.
Nice.
It seems that's where I'm going to be able to determine its frequency.
What did they say back in the day? There was a folk tale or something. I don't remember. That God loved a certain music, and it was played on, was it 12 strings or 24 strings? And I don't remember the exact story. I just remember hearing it once. That it was played in a certain amount of strings.
Yeah, I mean, I read the Bible a bunch of times. I have not heard
I don't think it's
about
in the
God.
Bible. It's something else. I don't remember where I heard it, but
Hmm.
it makes perfect sense here. If all the strings of the universe were there and they plucked each one of them, of course you would like it because you understood everything there was to understand about it.
Yeah.
I'll have to find that and I'll send it to you when I find it.
Yeah. Sounds good. So Yanni says, for clarity, right hand rule for me, it's direction of the fields. Lawrence Forest. Cheers, Eli. I used as an opportunity to mention it again. I thought that was more about our discussion. So Magneto says, Shawn, have you checked out my plasma work? I sent you ages ago. Seen my pics. There is a lot there for you to unpack. Might give you some ideas. I'm sorry, Magneto. Frico. Wondering how we'd connect. Are you connected to him in Facebook,
Yeah,
Nathan?
I'm pretty sure I am. Yes.
Can you? How would I get to him?
I'll send you the link.
Okay, so Magneto, I'll go through Nathan on Facebook, and then we can Facebook message
Oh,
and I can see your stuff.
he's got the green in there. Yeah, I'm absolutely connected to him. Sorry, Magneto. No, he's got the green in there. Trust me, you're going to want to see it.
Who's got the green?
You see his picture right here?
Yeah.
He deals with some gases and stuff like that, and welding and energy, and it builds out in a very particular way.
Oh, okay. This
Yeah,
sounds awesome.
You're gonna want to see it.
Thank you, Magneto, or Magneto. Sounds good. Awesome.
Yeah, we covered it on the channel a while back. It was a while back though. Yeah.
Okay, yeah. I'm sorry, Nathan.
We're good.
It's that same bat time, same bat channel. I apologize. I could do this all night if I could modulate my health a little bit better. I'm having so much fun, and you guys are so awesome. But I'm gonna have to say goodbye. Appreciate, Nathan, that you have me on. It means a lot. And I love your insight. And guys in the chat, you guys also, you always challenge me. And I just took a snapshot of the comments. So if I find any, hey, do this, do that on your experiments, I will try it like I tried some today. And you guys all have a good evening. And thank you, Nathan.
Yeah, dude, thank you for coming on, Shawn. And thank you for spending the time with us, dude. I love your experiments, man. You do an awesome job. Everybody in the chat loves you.
Thank you so much, guys. Much love to you all, and talk to you soon.
Right on, brother.
Bye.
All right, guys, real quick before we end the show, I just wanted to update real quick. I did get this thing going, so you saw it earlier. We have on each side of it, you can untwist these. I put an inset on each side, soldered it in, put the wire to it, and soldered it. Now we can just screw in the bolts themselves. I put a little tip on it on each side. You can see you can change the depth of them and everything else. This thing came out absolutely awesome. See, it looks really nice. It almost looks like a diamond cut on the thing because the actual fluid, I didn't get enough of it on there at the very end, and I should have. But you can see both sides will build out with energy. It's a bipolar, so I still have to put the #1 winding around it. That whole thing is working out. So we got an awesome job on that, man. And then there was, I just wanted to say this. We're doing this for Friday with Mike Faraday. Here's my thing to his. Okay, we're doing a wheel right here. We're trying to get perpetual motion out of it. I put each one of these at 30 degrees. The magnet goes on just like this. At 30 degrees, it minimizes the cross section of the magnet. It also has a shell on it. So the outside shell reduces the amount of magnetism by 50% at least. Therefore, my cross section is very small. I get a heavy section right here of a neodymium magnet that builds out in it. Now I can push this thing to rotate in a circle. So we're doing that. Hopefully I'll have it up and running by Friday. And we'll do Mike's channel with that, man. Pretty awesome stuff, guys. We'll have that #2 built here. I'll have a video out in the next couple of days. And man, it's going to be awesome. We got some cool stuff building out. Yeah, I'm going to use the ZVS on that thing because I don't have to use the ground at all. It because it's a north and a south, it makes its own grounding. It's bipolar, so both should spark off. Yeah. Yeah, I can't, honestly, man, I like the magnet thing. I thought it was interesting. They always say it can't work, perpetual motion. I just think they did it wrong. By the way, I was taking Tim Tron's advice. Get rid of the weight out of the center. Add the weight to the exterior. Yeah. Yeah, right on, brother. Send a video. Yeah. Link me anytime you can, man, if you got something cool. Flywheel understanding. Yeah, we're going to get into it. Guys, it's been an awesome show, man. Crypto, sorry for not sending you the link this time, man. You're out there at Tesla Tech making us all jealous. And yeah, I didn't know if you were looking into all that stuff or not on your email. So I'll make sure you have it next time. If you want the video or something, let me know, man. I'll work it out and get it to you. With that said, guys, I want to thank everybody in the chat, man. I want to give a special thank you right now to Ulysses, man. He hooked me up today, taking care of me, man. I appreciate that. Guys, you're absolutely awesome. We'll see you on Friday with Joe, and I'm sure we're going to explore every little detail of this thing because Joe's got a lot going on in what we're doing. So, with that said, man, have yourself a great day.
The old man Bill. The old man Bill. The old man Bill. The old man Bill. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.